This is how I left you in a mess. All these numbers again, all these numbers, all these calculations. Oh no, why do you want me to do this? Why do I have to go through it? And the answer is because it's good for you, right? This reviews a little bit of dilution. This reviews a little bit of molarity. It reviews a little bit of the math that's involved with the solution prep. So these things are good for you, not only for the competition, but also good for you in general as far as a science course is concerned, because these are the things that you're going to see when you go and take higher level science classes. So we've walked through now the process of making standards. We have to make standards because that's our way of telling the machine what's going on. The machine doesn't know, it's not that smart. You're smarter than that machine. So you've got to tell the machine, well, this is a concentration that I made. This is the area that you got from that sample. Now I weakened it, and this is the area that you got from that weakened sample. Then I weakened it a third time or a second time, and this is the area that you got for that sample. And it can take all of the data, or you can now, and generate what we call a calibration curve. So let's see what a calibration curve will begin to look like. So here's Excel. And to make a calibration curve, it's very easy. If you have all the data that's in front of you, it's very easy for you to do. There's two columns here, column A and column B. That's really all that we need to mess with. And column A will get the concentration. So I can put here concentration, and it's going to cut that word off or not include it in the entire cell. And if I want to click and drag it to include the whole thing, I can. And I want to put ppm here in the next row, just so that someone can interpret this and know what you've done. So units are always important, right? And then in the second row, I'm going to put area, because that's the number from the tables on that report that I needed. All right, so down here below, I can make this as fancy as I want to make it, but I'm not going to trouble with it. Down here at number 4, I can skip a line to kind of clean it up a little bit. I can put my first concentration that I made. And that first concentration was 1.034, so I just type it into Excel and I hit enter, and there it is. All right, well, if I go back and take a look at my second concentration, this was 0.517. So in cell number 5, I'll do 0.517, hit enter. And then the next one down, 0.259. So 0.259, and I hit enter. And there's my 3 standards, my high, my middle, and my low. We did all of those calculations in the previous video. On the report, when I printed these off and when I looked at that table down below, I saw areas that were associated to each peak. For my high one, if I go back up, my area was 3,371,244. Hit enter. The area for my middle one that I made was 1,741,725. Hit enter. And the area for my low one was 541,704, and hit enter. Okay, so I've now paired up the area that was determined by the machine to the concentration that I made. The next step is for you to highlight what you want Excel to plot for you. So I will highlight those rows and those columns. And up here at the very top, depending on which version of Excel that you have, you're going to see a tab that says Insert. So I'll click Insert. And I want to insert a graph. So over here in the toolbar, you're going to see some different types of graphs that I can choose from. pie charts, bar charts, anything really that I want. But what I'm focused on is just something called a scatter plot. I don't really want it to draw a line. The only thing that I want it to do is plot the points, and that's called a scatter plot. So I'll click the scatter plot icon, and I've got a couple of choices under scatter. One of these is just to plot the points. One of them is to plot the points and draw a smooth line. One is just to draw the line that's smooth, that connects them all. One is very rigid line that connects them all. And one is just the line itself with no dots listed that connects them all. Again, what I want is just the dots. That's all that this thing should be after. So I click just the dots only, and there's the beginnings of my calibration chart. The calibration chart should be linear. When I look at these points, they should line up in a line. They should not be curvy. One should not be higher than the other and out of sync or out of order. That means I've done something wrong. It needs to be linear. How linear is linear? Well, the scatter plot will show you. You just need to go in and make that setting change. So what I do is that I come up here at the graph, and I'm going to click one of the dots. It doesn't matter which one. Just click a dot. That way they all are highlighted. And then over the dot, I'm going to right-click. When I right-click, I'll scroll down to add trend line. A trend line is something that we use to see how good we were. How good was I when I made these cholesterol standards? In other words, how close to a straight line is my data? So I'll click Add Trend Line, and a nice kind of box will show up. And it says, well, what kind of trend line are you expecting? Well, I've got a linear trend line here. That's what we should always click. And down here at the bottom, you're going to see two options. One says display the equation on the chart, and that's something that I want to click. And the other one says display R squared value on the chart, and that's something that I want to click as well. Alright, once I'm done, I can close out of that box or hit OK, and there's my data. Alright, so I can click and drag this around if it's not going to be stubborn. There we go. I can drag it around anywhere in the chart that I want it to go, just to kind of clean it up, making sure that it looks good. So there we are. And if I look at my R squared value, this says 0.9894. Linear is equal to 1. If you are perfect with no mistakes at all, 1 is as high as you can go. If you have a calibration curve that gives you a 1 as a readout, then you can't ask for any better. You need to ask for a pay raise or extra credit. The further I am away from 1, the worse my calibration curve is. And I can look at this graph right now and I can tell you that my standard number 2, which is right there, was a little bit high. Because ideally, it needs to be lower to sit on this regression line. We call this the best fit line, on this regression line. So that means when I made this standard, I did something a little wrong. Maybe I didn't add as much water. I didn't take it up to the meniscus. Maybe there was a little bit too much in the pipette when I pipetted things over. Something was happening, though, with standard number 2 to throw this off a little bit. For a company, they really like to see a 0.999 regression line. If it's lower than a 0.999 or 0.99, they will typically make you go back and redo it. So in this case, if I was doing this for an employer, I would probably have to go back and make my standards over again. In particularly, standard number 2, because that looks like my problem point. But this gives me what we call a calibration curve. Now what I can do is that I can take the area of my sample. My area of the sample was 942,411. And I can use the calibration curve that I just made and use the area of my sample that I ran on the machine, and I can calculate the concentration of my sample. How much cholesterol was actually in the sample that I ran? Maybe this cholesterol sample came from a food product. Maybe this cholesterol sample came from a boiled egg. Who knows? And I want to know how much cholesterol's there. To do that, I need a calibration curve. To do a calibration curve, I need a set of standards. This is my way of seeing, okay, what signal is given to a 1 part per million? What signal is given to a half part per million? What signal is given to a quarter of a part per million, 0.25? So if I know the signal, I can then use that ratio and figure out, okay, well, what is my actual concentration? And that's the purpose of the line up here at the very top. Okay, so with the line, what happens is that I take the area of my sample, 942,411. Remember, on your calibration curve, area is the y-axis. So that means that number goes in for y in the equation. The x-axis represents concentration. That means that in this equation, x represents the concentration. So I'll take the area from my sample, I plug it into y, and I solve for x. So I got to get rid of this number first. So I add 274,738, and I hit enter. And that moves this number over to the other side of the equation, and now I'm left with 4 times 10 to the 6th times x. To solve for x, I divide each side. It's always the opposite of, right? Divide each side by 4 times 10 to the 6th. So divide it by 4, and 1, 2, 3, 4, 5, and 6. There we go, 4 million. And I hit enter. And that number represents x. X represents concentration. And because this was the area for my unknown sample, this is the concentration of my unknown sample. So that means that this sample that I have analyzed is 0.304 part per million, which also means milligrams per liter. So that is how we structure a calibration curve. It's convoluted, there's a lot of steps, but this is the purpose of the instrumentation portion of the competition. So leading up to the competition, you will come into the lab and you will run samples that you've made on our HPLC instrument to get these areas. And you'll take these areas for your standards that you've made, and you'll plot them, and you'll get a calibration curve. And one of the things that we will judge is how close are you to 1. Closer you are, you're going to beat the other teams out. The other thing that we're looking for is we're going to give you a sample. We know how much that you should be finding in this sample, and this is a sample that you will run. And we're going to be looking at how close your answer is to the true value. So for instance, I got 0.304 for my sample. We could have made a 0.35. How close are you to the actual number? That is something else that we're going to be looking for. The closer you are to the actual number, again, chances are you're going to beat out the other teams. The problem is that you won't know the true value. We don't want you to fudge the math. So this sample will truly be an unknown. You will not know the concentration of it at all. So you'll come into the lab, you'll have a series of solutions to make, you'll have some samples that you'll have to run, you'll load them up into the machine and you'll run them, you'll make a calibration curve like this, and you will report back the concentration of the samples. And that's going to be the hands-on instrumentation portion that's worth 50 points to the first place team. So big points, big importance. So get comfortable with this process. Many of you will require some training to come into the instrumentation lab and run the HPLC. We will give you a full-blown lab to do. You will go through the process of making standards. You will make these standards and load them up on the tray. You will then run the tray of samples as a batch. You will then print those reports off and make your calibration curve just like we did here. So you'll get that training. And if you need more than one lab for your team to understand what they're doing, we will provide you with more than one lab. You can come to us as many times as you need to come to us, but you at least need to come to us to complete one lab hands-on from beginning to end. That might be all that your team needs. But you might need a little more coaching because you don't feel comfortable with some of the things that are outlined in the procedure. Okay, so this completes the data analysis portion of the HPLC instrument. There's a lot of other things that we can go into, but we've decided not to touch it due to simplicity. This is awful enough, right? So this is all that we need calculation-wise, instrumentation-wise, and theory-wise to do a pretty good job in the laboratory when I get to that point. So any questions, you know how to get a hold of me. And I will probably be seeing you sometime soon for a laboratory meeting date. And maybe, just maybe, depending on what kind of mood we're in, we might just give you pizza too at the same time. Pizza? Forget about a calibration curve. Who cares? Pizza makes it better.